Welcome back. Today is lesson 1.5, the second half of it, day 2, properties of exponents. The essential question is, how can I simplify expressions involving scientific notation?
I'm just going to put with scientific notation.
Perfect.
It's just easier.
Fine with me.
Scientific, oh boy, notation. All right.
Okay, so scientific notation, we wrote a little note here, is a method of writing numbers by using powers of 10. That's what we're going to do.
Something times 10.
Correct. So let's fill in our table. We're
Okay.
going to do some examples. So scientific notation. Let's write something in scientific notation first.
All right.
Yep, times 10 to the 7th.
10 to the 7th. Okay.
Now let's write that in standard form.
Okay.
So we're going to rewrite the number,
So
1.275. And what it means, because it's a positive 7, you're moving the decimal 7 places to the right.
Okay, so move right.
Yes.
Okay, so we start where we're at.
Let's do
and
that.
We go 7 places. Holy cow.
All right, do this. 1,
2, 3, 4, 5, 6, 7.
And we
Notice how I left humps, because what are we going to add now, Miss Young?
zeros.
Zeros. Everywhere there's a hump, you add a 0.
Right.
So that's telling me that that decimal moved, so I have to write it all 1, 2, 7, 5 with 4 zeros.
Right.
And where is the decimal if we moved it?
At the end of the
So it
number.
would be right here.
And you don't even have
You
to
don't
put
need
it
it,
there
but that's
when
where it
it's
would
at the
be.
end. And if you needed to put commas in, I always start from the end
So do I.
and work my way to the left. So there's 3 zeros and then another 3, and there we go. 12 million.
Wow.
Let's do another example.
Okay.
This time with a negative exponent. How about
Okay.
3.5
3.5
times 10? How about we make it a little easier this time to the negative 3, so we don't have to
Okay.
move it so much.
Thank you.
So then I'm going to have Miss Boyd move a little bit over on the standard form so we have room, because we're going to move our decimal to the left. Correct.
Okay, so I'm just going to write that. Move left.
Mm-hmm.
So we're going to write this here, and I'm going to write it on this side now because we're moving to the left. But this time we're moving it just 3 spots.
Yep.
So moving it 1,
1,
2,
2,
3.
and there's our humps
There's
again.
where my decimal is. I'm going to add my zeros in. So I have 2 zeros I have to add.
Right. So now
So
if we
my
were
answer
let's write our answer.
is you start with the decimal.
Right.
I have 2 zeros and then the 3, 5.
Right. So there the decimal is critical. You need that
Okay.
because you have a very small number.
All right.
So now we went from scientific to standard. What if we switched it and we started with a standard number and we moved to scientific?
Okay.
So let's just use 1,325.
Okay. So where is the decimal right now if you never see a decimal?
After the 5.
Okay.
If you don't see a decimal, it's at the end.
Okay.
So now when you write something in scientific notation, Miss Boyd and I were talking about this, what are you looking for? Where's the decimal going to end up?
Well, I'm going to need it over here somewhere.
Yes.
And I would like it between the 2 numbers that are farthest over.
Yes, and that's always how you do that.
Okay. So I'm going to need 1.325.
Yes. Times, because we're going to write it in
Times,
scientific notation,
10.
10.
To
And
the
we moved it 3 places to the left,
2, 3. Okay.
and so it is a positive 3. When it's a bigger number like that, the exponent is going to be positive versus
So
negative.
Positive exponent. Then the number is big.
Yeah.
So we got a big number. Okay.
So now let's try, how about 0.000, so 3 zeros, 46.
Okay.
So now remember, again, to put it in scientific notation, the decimal point, has to be after the 4. You cannot your leading digit cannot be a 0.
Okay.
Your leading digit must be a number greater than 0,
but
less than 10.
Okay. So 4.6
times 10.
Oops. I didn't do
Get that? Okay.
Times 10 to the
And we
And
moved
since
it.
it's a small number, it's got to be
We moved
negative.
it 4. Right. It's a smaller number, so it's negative.
Okay, so I'm going to write that too.
Yep.
Negative exponents go with the small numbers.
Right.
All right.
Okay. Let's move on to the next page here. So let's do some examples.
Okay.
Example 1. All right, so we have an assigned number in scientific notation in the top and the bottom.
Okay.
So, oh gee, what are we gonna do here?
Let's do this first.
I like
Way
that.
easier.
Right. So you're going to probably need a calculator here.
Okay.
And if we type this into our calculator, let's ignore the 10 to the negative 5 right now. Let's look at the number in front.
Okay.
When you're dividing, which is what we're doing, you're going to take your calculator and type in 4.5 divided by 1.5. When you do that, you're going to get 3.
Okay.
And to be legit here in scientific notation, you can write just 3 or you could write 3.0. Either one is correct.
Okay.
Times 10. Now notice, you have a base of 10 divided by a base of 10. They're the same.
Oh, so we can just subtract their exponents.
So negative 5 minus 6 is a
It's a
negative
negative
11. Now I can go ahead and write negative. Now I know in the last day 1, I said never leave your answer with a negative exponent. In scientific notation, it is okay.
We just leave this.
Let's do the next example.
Okay.
Now we're multiplying. So let's do the same thing we did before.
Okay.
We're gonna multiply.
Because our bases are the same.
Yep, let's look at those.
So we'll multiply our numbers out front.
And if you type that into a calculator, 4 times 3.1 is actually 12.
It's actually 2.6 times 8.5.
Oh, I'm sorry. I'm looking at the wrong example.
It's okay.
When you do that, you get 22.1
Okay. So we have 22.1
times,
times 10. And then when you have those, we add them.
correct, 7 plus 4 is 11.
Ooh.
But-
But like you said earlier, the number has to be greater than 1, which it is,
Right.
but less than 10.
And what she means by number, the number on the left of the decimal.
Yeah.
Or the number itself, yeah.
Mhm.
So basically, we have to move that decimal.
Okay.
1 to the left.
So we got to move it left.
So the final answer then will be 2.21 times 10. And I'm going to have you just write this, and then we'll
Yeah.
explain it, to the 12th.
Okay.
This is a rule you want to remember. When your number, the 22.1,
Mhm.
whenever that gets smaller,
So we went from 22.1 down to 2.21.
your exponent will go up,
So they
By-
go opposite.
right? And in this case, it's going up by 1 because you
Because we
only
only
moved
moved it
it
one.
once. If you would have to move it twice, it would go up by 2.
Got it.
So that gets smaller, the exponent gets bigger.
All right.
Our next screen. So do we want to go through this one, or should we save maybe both of these for class? Well, actually,
Let's
we
go
should
through
do the first one. Yes.
And we'll skip
Okay.
the last one.
So again, grab out your calculators.
So we're gonna do
2.325 divided by
divide.
9.3 is 0.25
2.5. And we got
times,
the times 10.
and you're going to subtract the
And we'll subtract,
exponents.
so 6 minus 9
Is negative 3.
So negative 3.
But again,
Yeah.
the number 0.25, it's not greater than 1.
Yeah.
We have to make it greater than 1 by moving the
Gotta move
decimal
it.
to the right.
Okay.
So we get 2.5.
So we made this bigger.
So we have to make the
so then
exponent
exponent goes
smaller,
Smaller. So it
which
goes
will
to
be
negative 4.
correct. And you're done.
Awesome.
Let's finish the next example in class
Yeah.
tomorrow. Here's your video questions. Have a great night.
Bye.